Hello and welcome to my channel. So today let's look at today's daily challenging question. Leetcode 993, cousins in binary tree. Given the root of binary tree with the unique values and the values of two different nodes, x and y, return true if the nodes corresponding to the x and y in the tree are cousins, or false otherwise. So the cousins means they have the same depth, but they have different parents. So um, binary tree, the root node is at a depth 0, and children of each node, depth k node are at the depth k plus 1. So for this question, we can use a method called BFS, or breadth first search, to traverse by level order. To traverse the tree in level order. So the level order means firstly you look at the level 1, and then you look at the nodes in the second level, 2 and 3, and then you further traverse the third level. So then when we are in the level, we can keep a count. Like the count will be count will increment. We keep a count if and increment if we meet x and y, or y. Then in this level, if the count after traversed all the nodes in the same level, if the count is 1, which means we only encounter one x or y in this level, then it means we need to return false. So if its count is 2, then we actually encounter both x and y, so we need to return true. Also notice that all the nodes are unique with unique values, so x will not appear more than once in the tree, and y same for y. But if count is 0, means we didn't find the count in didn't find x or y in this level, so we just continue to search the next level. And also we need also to check if belong to the same parent. So this can be done when we add nodes to the queue, which is used for the breadth search. So if they belong to the same parent, then we need to return true false. So this is the main thought process, and the time complexity will be O(n), and space is also n, because we are using a queue. Maximum nodes we put in the queue is n. So now let's start implementing. So firstly, define this queue. And we can add the root to the queue. And next is if we can start the main loop for the BFS. So then we need to get the size of the, because we need to do it by level. So we need to get this size, the current size of the queue. And then we can do the loop while size larger than 0, and the size need to decrement. So then inside this loop, we can start removing the node from queue. And remove each node, after remove each node, we can we can add the node. So we can actually do a check if the parent left is x or y and y is right is y. So yeah, so if node this node left is x and this node right is y, right value. Or similarly, if right is x and left is y, then we need to return false, because it means they belong to the same parents. And then we can add the node to the queue. Similarly for the right. Yeah, and also as I said, we need to have a count, which will count the x or y. So if this current value is equal to x, or current value is equal to y, then we increment the count. So then after this while loop is done, then we can check if the count is 1, then return false. Else, if the count is 2, then return true. If the count is 0, we do nothing. We just go searching the next level. So then, so if after, so we can just return false in the end of the end of the code, this function. So to avoid the compiling error. So it means we didn't find like x and y. So that if the count is 0 in each level, then we didn't find it. But it's actually in this question, you will always find x and y. So yeah, because x and y exist in the tree. Yeah, let's check if the code is correct. Okay. Okay, so this concludes today's daily challenge. If you have any question, please comment on the video, and thank you for watching. See you next time.